Find all the values of x such that the given series would converge. Okay. How do we know if a series converges? We do what's called the ratio test, what we normally do. Ratio test says the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n, where that's less than 1, the series converges. Why? Because the next term over the previous term, the ratio is less than 1, meaning the next term is smaller than the previous term. So this fraction is less than 1, meaning the next term is always smaller than the last one, meaning the terms are getting smaller and smaller and smaller. So if you add them up to infinity forever, they'll still come to a finite sum because they're getting smaller and smaller and smaller. The series will converge. So wherever that happens, the series converges. So that's what we do. We take the limit as n goes to infinity of that series. Okay. So now we're going to do the absolute value. So we don't care about -1 to the n. That just changes the sign, plus, minus, plus, minus. We're doing absolute values. So we don't care about signs. So x to the n plus 1. I'm plugging in n plus 1 right there, n plus 1 right here. It'll be n plus 1 plus 8 over, and n plus 1 right there, 11 to the n plus 1. Okay, now that's going to be over. So that's a sub n. Sorry, that's a sub n plus 1, right? Then we're supposed to put that over a sub n. What's a sub n? Well, that's the whole thing just to the n. That'd be x to the n plus 8 over 11 to the n. But we don't want fractions over fractions. Instead, flip that up and multiply by the upside down because dividing is upside down multiplying. So we'll just do that times. 11 to the n, that'll now be on the top, x to the n on the bottom, n plus 8. The absolute value of that is less than 1. Wherever that is, it converges. Okay, so how are we going to deal with that? Well, this will be the limit, and goes to infinity. Oh, this is 11 to the n times 11, right? To the 1, right? Because those powers will add to go back to that. The same thing with this x to the n, x to the 1. Those powers will add to go back to that. This is plus 9 times, and then the other one, to the n, x to the n. Let's say, where's the absolute value? Less than 1. Well, let's cancel out some stuff. X to the n cancels x to the n. 11 to the n cancels 11 to the n. So that's nice. What are we left with? I'm going to either cancel or circle. So x, put that there, and then 11 to the 1 is 11. What else do we have? N plus 9 over n plus 8. So I'll put that, I like to put the n's all together. N plus 9 over n plus 8, absolute value of it, less than 1. So now we're going to infinity. So if you're plugging in infinity plus not for n, right, and infinity plus 8, the plus 9 and the plus 8 don't do anything. Who cares? It's just n over n, right? It's x over 11 times n over n less than 1 because we're going to infinity. And so those just cancel. It's just 1. So we get the absolute value of x over 11 less than 1. Multiply both sides by 11. Boom. Absolute value of x less than 11. So that is my radius of convergence. That's the first. Well, that means, let me go to a number line for you. That means here's 0, here's -11, here's +11, right? X is anywhere, between that. That means X is between positive and -11, right? You can put in something like -9, and the absolute value of it will be less than 11. Even +9, the absolute value of it will be less than 11. Anything there. You can't put in like -12. The absolute value of -12 would be positive, wouldn't be less, right? It just goes from -11 to +11. Absolute value of x less than 11 means x is between -11 and +11. So that's first off our left endpoint, right endpoint, right? Series is convergent from that to that. But what about the endpoint? It's saying no and no. Why? Hey, so because sometimes it's yes, yes for one of them, yes for both of them, yes for just one or both can be yes. Why? How do we know? Like right when you're at this endpoint and x is -11, or you're at this endpoint and x is positive. We know we go parentheses, right? But do we go right on? Sometimes we do, sometimes we don't. How do we know? Well, let's check them. Let's check them one at a time. So if I go back to this original series, let me it's plus best place to do it. Let me just go to this. Let me just do it right here. I think maybe. So I'm just going to take this series and I'm going to plug in first off the negative 11 for x. I'm going to let x be negative 11, plug it in right there. So what does this mean then? This is the sum of negative 1 to the n, negative 11 to the n plus 8 over 11 to the n. So what's going to happen to that? Well, basically, these are going to cancel out, except it'll leave a minus 1 to the n term. So that'll be the sum, minus 1 to the n, minus 1 to the n plus 8. Minus 1 times minus 1 is plus 1 to the n. And so this is the sum of plus 1 to the n times n plus 8. And so plus 1 to the n. Now, if you start, let's just see what these terms are like. We're going from n equals 1 to infinity, as it said from the beginning. If you plug these in, plug in 1, for example, you'll get 1 to the 1 times 1 plus 8, 9, plus, and then now plug in 2. Plug in a 2 there, and there you're going to get 1 squared, and then 2 plus 8 times 10. Plus plug in 3, 1 cubed times 11. Plug in 4, 1 to the 4th times 12, etc. See what's happening? So those ones aren't doing anything. And so really we're adding up 9, 10, 11, 12. We're going to do that forever. What's going to happen? It's going to go to infinity. Obviously. It's going to, we're just adding up bigger and bigger numbers, right? So it's going to infinity. And I don't know if you remember the divergence test. The divergence says, hey, if the individual terms themselves, they have to go to zero to have any chance of adding them up forever being finite, right? It's saying if your individual terms are not going down to zero, then for sure if you add them up forever, it's going to be infinity. And that's what we see. If you add it 9, 10, 11, 12, keep going forever, that's going to, be infinity. The terms themselves have to go to zero. And they have to, and they have to go to zero fast enough so that the total of them all forever is finite. Sometimes they go down to zero and they don't do it fast enough and the total still goes to infinity. But if they don't go to zero, for sure it's infinity. That's what the divergence test said. So that's infinity. So the negative 11 is not included, right? So I plugged in x is negative 11 and right there for x, and we worked that out, and it ended up being this. What if you plugged in positive 11? Well, it's gonna be the same thing. It's just gonna be negative and positive and negative. It's just gonna change the sign, right? If I plugged in positive 11 here instead of negative, then you won't have that negative one. So this you won't have that other negative one. So so this will stay negative. This will be negative 1 to the end, but that won't matter. This will just be like negative 9, positive, negative 11, positive. Who cares? The terms are still not going to zero. It's still going to be infinity. So that one's a no as well. So you just plug in the endpoints and then look at what you got. These 11s cancel. And so you got n plus 8. In the end, you get, who cares about the signs? You get n plus 8. That's going 9, 10, 11, 12, and not going to zero. So for sure, the total is divergent to infinity. So it does not converge at the endpoints, negative 11 and positive 11, but it converges everywhere in between. From negative 11 to like negative 10.99999 and positive 10.99999, everywhere in between, right? Anywhere between negative 11 and positive, everywhere in there it'll converge for all those x values, but not right at negative 11 or positive 11. We can tell because you just get n plus 8, which is going to infinity. And so there we go.